let's practice more with significant figures in mixed operations. Let's take a look at a couple of these examples here. Notice that they have mixed operations. You've got some addition with multiplication, you've got multiplication with subtraction, so forth. And we have different rules on rounding and significant figures when we have mixed operations. So let's try this number 18 first. Here we have 5.30 times 11. Then we're going to subtract 4.2 from that. Okay. First we do the parentheses. We follow our standard order of operations. So we have 5.30 times 11. And we get 58.3 as our answer for what's there inside of the parentheses. Now we know that multiplication and division, we have to look at the number of significant figures in each measurement. Okay. This has 3, 530, and 11 is 2 sig figs. So whenever I carry this 58.3 forward, I'm going to remember that actually there's only 2 sig figs that will be carried forward. It's going to be the 58. Now I will not round this just to 58 at this moment because I need that 0.3. I don't want to round an intermediate answer and then round a second time on the final answer. But I do have to remember that only the 58 is truly significant here. So now I would have 58.3 minus 4.2. So I do that on the calculator. Subtract 4.2. Oops. 58.3 minus 4.2. I get 54.1. Now, here I am doing subtraction. I have to remember though that only the 5/8 is significant in the 58.3. The 4.2 is 2 sig figs, but I'm doing subtraction. And with addition and subtraction, I have to look at the digits of precision. I have to look at the decimal. Okay? 58 is what I'm using, not 58.3 in terms of significant figures. That is 2 sig figs with no digits of precision, what I like to call no dopes, no digits of precision. I'm subtracting from it 4.2, which is also 2 significant figures, but I'm doing subtraction is the operation I am doing. In subtraction, I have to look at the digits of precision, the decimals. 4.2 has 1 digit of precision. So I'm subtracting 58 with no digits of precision, 4.2 with 1 digit of precision. When I do this subtraction and I get 54.1, the answer though must not have digits of precision. It has to match the value, the quantity, with the fewest digits of precision. So my final answer here will be 54. That's the final answer. Okay. Let's try a second one of these. Let's attempt number 17. We have 3.111 plus 5.03, and then we are going to multiply that by 33. So we use our calculator. 3.111 plus 5.03, we get 8.141. Now 3.111 has 3 digits of precision. 5.03 has 2 digits of precision. So I have to remember on addition and subtraction that I focus on digits of precision. So this 8.141, I'm actually going to only use 2 digits of precision. So in my mind, I have to realize that 8.14 is the significant true value. but I don't want to round off an intermediate answer only to a second round a final answer. So times 33. So we put that on the calculator. The calculator says it's 268.653. Now, in my mind, I know that 8.14, those two digits of precision, is what I'm using. And I'm multiplying it by 33. In multiplication and division processes, I look at the total significant figures in each value. 33 is 2 sig figs. 8.141 is 4 sig figs, but I'm only allowed to use 2 dopes in this calculation. So 8.14 is 3 sig figs. When I multiply, my final answer must have significant figures equal to the lower amount, 2 sig figs here rather than 3. So I get 268.653, and I'm supposed to round this to 2 sig figs. For 2 sig figs, I would go 270. Right there, the 2 6, I look behind it, see the 8 would round it up to a 7, so I'd have 270, and I do not put a decimal there because a decimal would signify that trailing 0. That trailing 0 needs to be insignificant here, so I will not put a decimal there. This will have 2 sig figs. With a decimal, it would signify that trailing 0 and would give me 3 sig figs. Here I need 2, so 270, no decimal, is my final answer.